Yeah.
Okay. Hi, everyone. Welcome to this week's discussion. So for this week, we are gonna discuss about the lecture 13, atmosphere ocean coupling, WRF and FVCOM coupling model. And before the class, I have received one question from the online discussion board from Minwoo Park. Minwoo Park, would you please to see more detail about your question?
Okay. When a hurricane passes over the ocean, a strong vertical mixing brings cold surface water to the surface, forming a cold wake behind the hurricane track. In this regard, I think that not only sea surface temperature, but also the vertical structure of ocean temperature is an important factor when simulating hurricane test. So, however, in FVCOM WAP coupling, as far as I understand, the ocean temperature information provided from FVCOM to WAP is limited to sea surface temperature. Therefore, I would like to ask why only sea surface temperature rather than the vertical structure of ocean temperature is transferred to warp in coupling. This is my question. Thank you.
Thank you. So this is the only question I received before the class. So is there any other question related to the atmosphere ocean coupling or other physical oceanography questions? No? Okay. Another question is from our last class. So due to the limited time last week, so Jimmy Seal asked this question. So I want to double check Jimmy Seal. Is this question fully answered? Do you have any other things that you want to know about the data simulation?
No, I have no other additional questions.
Okay, thank you. Okay, so this week we only have this one. So
not many people interested in the LC coupling. That's not doing,
yeah, so I will. Okay, so if there is no other question, so let's start with this one.
So Siqi, you want to answer the question?
Oh, okay, yeah.
Okay,
So
try, okay.
Yeah. So Miu Park, I think this is a good question, and I think you're absolutely right that the ocean vertical temperature structure and the ocean heat content are are both important for the hurricane intensity simulation. However, in our current FVCOM WRF coupling or the other ocean atmosphere coupling model, only the sea surface temperature, as you mentioned, is passed from the ocean model to the atmosphere model. The reason is that currently the WRF structure, the WRF air sea flux parameterizations depend primarily on sea surface temperature. It does not include the ocean vertical physics. So that is to say, if you provide the vertical temperature profile to the WRF model, so the WRF model will still only take the sea surface temperature into its modules. So therefore, the SST serves as only an effective first order representation of the ocean feedback. So that is why, although the vertical structure is very important, it would require a more complex, fully coupled ocean atmosphere model system that we could make the ocean model feed back the other information to the atmosphere model. Yeah.
Let me add something, okay? The first things, okay, ST here is not a satellite ST, that's a couple model reduced sea surface temperature. So this one has been included like a result due to the cooling, due to the vertical structure ocean. Okay, that's just different for a satellite. You say SAT data like satellite data, okay? Surface temperature data. That's just a couple months to produce the surface temperature data. The second is you look about the LC coupling. So most LC coupling goes through the LC interface. Okay, it's not vertical. Okay, so because your vertical structures, the vertical temperature structure changes, then they can be affected the surface temperature. After surface temperature, they go through the LC interface. Okay, then exchange the data with the ocean model. So that's why the coupling system don't need to include the vertical temperature structure. Okay, because the vertical temperature structure is be changes, okay, the surface temperature. Then the surface temperature provided to the ocean, provided to the WRF model. The reason because the LC coupling we understand right now is all goes through the interface. But interface is the surface. Okay. So most important things recent study right now is talk about skin temperature. Okay, skin temperature means you model predict ST data, but temperature data is the surface, but you model not really surface. Right? Because you model all the ST data you predict the surface temperature is the most like a center of the first layer. Right? But then the question, then the good things you need to do, so you need to determine the skin temperature, exactly the skin temperature, just like a LC, kind of boundary. Okay, but that's kind of boundary, how thin is? It's about a millimeter to centimeter. Okay, that's a LC temperature, the boundary. People talk about a turbulence, talk about turbulence. So they talk about as vertical changes about the flux there, but that's on the millimeter and centimeter. Okay, but now the model we use right now, because it's a company has not able to resolve this kind of scale. That's why we just use the surface temperature, but surface temperature did include a cold wake, right? When if for example your atmosphere cold, the storm come here, for example, you got a cooling, for example, right? So then the cooling system go down, they mix the water, get a deep mix there, they bring the cold water in. But when the cold water onto the surface, they change the surface temperature. But that's kind of change will be feedback go to the WRF model. I look at your question, I saw that so you said, oh, I should have included water structure. No, you couldn't. You should not doing that. Okay? Because no matter what changes, that's a two system. Okay, if you look at my lectures there, you got a converse system there. You got two systems. One is the atmosphere, one is the ocean. Okay, that's completely different. One is the air, one is the water. All the water exchanges, all the heat budget exchanges, all the sensor exchanges, is the LC interface boundary. That's why you need to provide to WRF is ST data. Okay, the only things we have to be considered is another issue, because atmosphere water has a thermal boundary layer, right? So if you have a bottom roughness changes, the surface boundary changes, because if for example you have a wave, you have an ocean wave, the wave changes the surface roughness, right? So surface roughness should be included in the atmosphere boundary condition. So that's why if you're really interested in turbulence, that should be included. But also must be on the interface, not the vertical structure. Okay. So that's the reason. But that's why, that's why so far we do ST, but if we really want to do a small scale turbulence, we should consider about the ocean wave, how they change the body roughness, then affect it in the low atmospheric boundary condition, because the primary boundary condition aid the body. Okay. But most right now, if you go to look like a wolf, they get a lot of boundary condition. They get a lot of option, choose the boundary condition, but they was considered for just like some kind of polarization. Okay, but I don't think that either one has included wave. Okay, structure. But if you don't include wave, their polarization probably okay, right? They can probably relate to temperature or that something. You can have many options. Though I think they had more than 6, kind of boundary theory into the model. Okay, but your question is make your long answer to short. Your question is you should not include the vertical, temperature structure in the ocean into the exchanges. No. Okay, you only need to consider as a ST, no surface temperature, not the satellite ST data. Okay, because this ST was be changes due to dynamics. This ST should include resolve the cold wave information, right? So you can look about a Lee's paper published in the Program Oceanography. They will show clearly how this kind of cold wave can intensify the hurricane. And a lot of argument for hurricane. If you look at the Kerry Emanuel paper, Kerry Emanuel and MIT professor Kerry Emanuel, he had a theory. His theory is based on, what can be intent, in fact the temperature, and how you get temperature can affect the hurricane. Now he said if one sea surface boundary condition, so you get a stronger hurricane. If you look about Kenneth's equation, you can show that. If you look at his paper 2003 paper, review paper, that is because that is what he mentioned, that the temperatures really affect the intensity of the hurricane. So that's why if you get a warm, the background surface, you get a stronger hurricane. But that is based on when the hurricane started, right? When the hurricane is the equatorial region, so when you get a warm surface area, you can develop more. If you got a warmer warming, you get a more stronger hurricane. But then what we're talking about the coupling is another thing he did not study very well, is about earth interaction. But that's what happens when you want to form the hurricane, you need to get a warm surface, right? You can develop a hurricane, you can develop quickly, hurricane can be developed quickly. But when the hurricane moving, right, the moving during time, the earth interaction can be critical. Okay? So that's why the people argue, said, okay, you said a cold pool can intensify hurricane. Why, the basic theory should be warm water, should be favor to hurricane intensification. Why you say the cold water can do that? Right? The reason is the cold water can do it, cold water can be bring here, he can make the hurricanes more asymmetric. You get a heat budget was asymmetric. Ask increase grading, change the pressure. Pressure can change after the pressure changes. They can change the wind speed, the wind hurricane shape. That's different. So people always had a confusing, issue. Say, oh, you should get a warm water. It can be make a hurricane stronger. Why you get a cold water? That's different. One is talking about a larger background, right? Now what happened? One another talk about the inside the hurricane, how to interaction could be. Okay. Now, who has this question? It's a Park. Do I answer your
Yes.
questions? Window Park?
Yes. Thank you
Okay.
so much.
Yeah. If you have any question about a hurricane, any question about we're happy to address. Okay. But that's
Okay.
why you should not include the vertical temperature profile in the coupling because all LC interaction go to the LC interface. That's the boundary layer. It's a layer interface, not the whole layer. Okay. All right.
Okay.
So deep water information, not a direct flag. They had to change the ocean boundary condition, then change it, then feedback to the atmosphere model. They're not able to, direct affect that. Okay. Other
Okay.
question?
Oh, uh, yes. It's very helpful. Thank you so much.
Okay, good. Yeah, any other question we can have, we get a lot of time, we can talk about, not only for modeling, for all others, we're happy to address. Okay.
Yeah, be active. Feel free to ask any questions. This is our last discussion for the semester. So any questions related to the numerical model, FVCOM, oceanography?
Yeah, we can probably, if you don't have a question, I can introduce something we're working on at FVCOM right now. The four things that we have introduced, the hybrid coordinate into FVCOM, because now the FVCOM is used like a generalized topographic coordinate system. But that system, when you have very steep bottom topography, so you probably meet some problem. Okay, you can meet some problem because you have to have a resolution very high. If you, for example, you have a very steep topography, you need to have a horizontal resolution, high resolution, and reduce the topographic coordinate error, numerical errors. But it's okay. You can do that, right? But then, because when your resolution, for example, you run regional model, like the C mount, like region, so you have to make it near the C mount a very high resolution. Okay, so that's limited. Some people don't have a supercomputer, don't have things there. You can limit your application. So now what are we doing there? I have some slides here. We have to introduce the method. Okay, just like a hybrid coordinate method. So that's what it means that, we can select the two coordinate system in the vertically. Okay, one is like a like a surface. You can see the shallow water. You do want to have a topographic coordinate system because you get an estuary, a lot of region there. So, they don't have a lot of sigma error because the water is shallow. So you want to have a topographic coordinate system. But a deep ocean, for example, you apply the FECOM for global ocean, right? So this way you don't want to have the signals, topographic coordinate, topographic coordinate system in the whole water column because 4,000 meters. Right? So for example, if you have a 4,000 meter, you choose like a 40 layer. So you change the 40 layer, only 40 layer in the 4,000 meter. That means each cell, the vertically you go to like 100 meters. Okay, but if you have a C mounted there, topography there, if your resolution not high enough, so then you can cause the larger sigma error. You probably get outwelling, it's not a true outwelling. So then what happened? So reduce like the artificial outwelling, also sigma error, what we call sigma error, so also topographic coordinate error. So we introduce a hybrid coordinate. Okay, this way, okay, we can do the better. Okay, show how these things can be working. So with the coding has been almost finished. Okay, so now Dr. Chia has working on the coding, so it's almost finished. So he said in the early May, I hope early May, because he's a very careful person. He had to check a coding. He finished the whole framework structure. So you use the model, you should like FE before, but only input file, NAND list a little bit different. But then the problem, so then problem we need to test the coding. So he has been okay, coding most developed. Okay, so so then hopefully, we will be able to test the coding very soon. Okay, it was I think we in the early May, so we should able to do that. Okay, so I think I had a slice here. Let me find the slice if I can find the slice here. Do we have a slice here? Last time I gave it a Nova talk. Okay. Okay, which slice I give to? Siqi, do you keep my slice?
Let me check on my side.
Yeah, I had a picture show the coordinated system.
We
The hybrid coordinates, I give it to Nova last time. I gave a short talk. So I don't know where I put. So should it be in the 2025 or the meeting or 2020? Okay. Okay. Let me see. Do I have here? November? Let me see that. No, this is a review. That's a review. I don't 3D. Okay. I do see the Q1 3D WASC here. I don't have here. No, I don't have here. I think I just had a couple slides show the how coordinated it is. Okay. Let me find it here. Let me find it in the FVCOM environment. Do other people have a question? Okay. I think okay. Let me try to find it. I want to show you the coordinate how to work. So I did like a I give a note for you, right?
yeah, no, I have the note.
Yeah, let me see that. Okay. So I should have put it in the coordinate system. I couldn't find. Let me see. I didn't prepare. That's really no. I saw that just people was talking about a hybrid coordinate pressure calculation. Okay, okay. No, that's the figure I have here. FVCOM update. No, I don't think I have here. No, I don't have here, but anyway, I just show you what we do. Okay. So, if this way, if a coding there, so you can apply the on the global ocean and it is much easily. Okay. So we hopefully in the end of May, so we get some primary results, we can go to test the coding. Okay, that's what I would think about we can do. Okay. All right. So I think I give the talk in the December. I think it's what day I give the talk.
I think it should be around January 20th.
Oh, yeah. That's I found out. I found out. Okay, let me show screen. Okay. Here, you see what happened? Have everyone able to see that? Okay, let me introduce the coordinate system here. Let me show the PowerPoint here. Okay, you see this happen? You're able to see that. When FVCOM was developed, So we include a generalized Brand following coordinate transformation. So then the basis on, like papers, like a pie, pie chart, the paper. So we talk about it, quality system use this formula. Okay, this formula you can choose like a up layer, the low layer, up layer, low layer. So you can choose the thickness. So you can choose like a coordinate system. So you can make a coordinate system like a S coordinate uniform, uniform layer in the surface, uniform layer in the bottom layer. The surface. Then you can get a shallow region. You can do the sigma coordinate. That's called a hybrid coordinate system, but it's horizontally hybrid. Okay, horizontal hybrid. So then you can link like a system for S coordinate, then the sigma coordinate together as some region has a uniform layer. So that's why it can continuous transform. So you can have this S coordinate is good. You can get a uniform sigma surface mixed layer bottom. So then sigma coordinate you can do the wetland into zone, the flooding area. But then what are we doing right now? So we are shifting this one to here. So this is the new FVCOM system called the vertical hybrid. Before I show you the horizontal hybrid, now we get a vertical hybrid. What really happened, so we still keep everything same FVCOM in some region. We choose to call a depth H underscore S, HS. So this steps here we can use user define how much high is. You can choose like a vertical high coordinate. You can still use S coordinate, horizontal sigma coordinate. The horizontal uses the up layer, but in the deep ocean, we was adopt called a ship Z coordinate. So then there's two coordinate system put here. This way in the steep bottom topography, you don't need to worry about a sigma coordinate. You can choose the coarse resolution. So then you can use the constant layer depth. But then the big issue is how you treat the boundary condition, near the slope. That's called a ship Z coordinate. Okay. So then we had a block. We had a two block right now at FVCOM. One is called the up block. Okay, so then we steer the terrain following coordinate. We get thickness, before we get a zeta is the surface plus capital H S. That's the total depth. Now we define it is the HS like a user defined depth you want to do. So in this one, you still can use the all FVCOM original one, but we get a block low. So low block. So we can ship the coordinate. So they're defined by that's the total depth, H, then minus, minus small, the HS over here. So we call this deep region. In the deep region, we use the ship Z coordinate, right? So then user can be easily defined. Okay, so if you was a user, you can choose this one, so use this one, you can use the HSR, the reference. That's a reference, constant target transition depth. Okay, so this one always choose the minimum of this two. Okay, then this, but most time, SA, HS equal to H, SR, right? The shallow region. So then what will happen? You do this one here. Let me see. So when you do this one here, so if the H is larger than SR, you can HS equal to SR. But if the H smaller than this one here, so then you automatically choose HS equal to H. As you go back to sigma coordinate. Okay, so then what transition, so you can do the ensure how the continuous equation transition in the minus H, so the kind of HS. So transition interfaces was shown a two block, one block here, there's two blocks with shown here. So get a transition. Okay, So one is sigma, one is H. Then you get a transition over here. So that's what a coordinate is. Okay. So how to approach that? You see how to approach that? So we was developing a module calculating the pressure based on the control volume with a continuous push in the up and the low blocks. Okay, the continuous pressure grading is calculation module is code. And Dr. Lee has tested that. It's working very well. So then we update the increased vertical, increases the vertical advection and the diffusion solver to drive the water current into the up and the low block. Okay, coding modify. That's the structure, how to do vertically, how to transition. You see that this, that's the velocity, how to transition. I don't want to go to detail. So we get a continuous boundary condition. We upgrade the vertical velocity, computation module with a continuous condition at the transition level. So we also build like a mask grid module down. So far we don't need the, I think Dr. Lee and also Chi has a great idea. Just use the water depth to determine where it should be, water should be, in the layer 1, layer 2. Okay, where is the land? Determine the bottom boundary layer node, and the low block reminder, MPI, configuration. So that's the whole boundary condition, how to stretch calculation, how to change there. I probably don't get too much. I just give a simply discussion. But the coding has already.
Hello? Hello? Uh, can anyone hear Dr. Chen or from
No,
me?
I think Dr. Chen have some problem, I think.
Oh, okay. Oh, okay. Maybe when Dr. Chen quit the share screen, he quit the Zoom.
PowerPoint 5, they was lock me out. Okay.
Mm.
So, anyway, so that's basically what I describe right now. So I think that after the code developed, FVCOM can be really powerful global ocean for, also can be doing like a larger scale, circuit, so applications. Any question? Any question about the new FVCOM structures?
Professor Chen, I'm outside, so I cannot turn on my camera. I think it sounds really wonderful. My question is, we continuously saw many issues due to the MPI, the blocks. In that the upper block and lower block, how about how those block can be dealt with the MPI structure?
Okay, that's a very good question. Before we think about it, we introduce called a mask file. Just you still use the every grade point. You still use like for example, you get a horizontal grade. You only do it one time. The grade will show the no, in the low block, the partially because coast region is land, right? It's no water. Okay, so this way we use the mask way to determine that, to separate that. But then the question now, because your FECOM calculation each block, the parallel based on the layer, right? So now, Dr. Lee and I think it's Dr. Chi, Chuck Chi was thinking about we don't need a mask file, so we can use the water depth determine where is should it be low block or it should be up block. Use water depth. You see the water depth I give there is H equal to no small, like capital H equal to the HS, something like this. So you can use this water depth to determine you was in the block, in the low block and the up block. Because your parallel rounding is each layer. That's why in the low block, they only had a rounding the model in the region had water, had a sear. But all the sear you use, to create it horizontally, you probably in the land. So this one is not calculated. They automatically determine if the water depth is shorter than that, they don't do the calculation. That's why you can make the computer more efficiency. You still get a parallel. Parallel don't need to change anything. Okay. Do I answer your question?
Yes, yes, that was wonderful. How about other capabilities such as dike modulation, something like that? Can those modules can be also used?
Yeah, that should be no problem. I don't think it should be. Now you only now with the die module we right now is a sigma coordinate, is for sure right now. But when we apply the die module for hybrid code, you need to modify the code. But you had to use the we had to be put our vertical definition, the grid setup, a whole setup, moving from FVCOM to the die coding, offline die coding. Online you don't have a problem. Online you don't have a problem, but online take time. But offline coding we need to modify the coding. But that should be not straightforward. Because you usually need to move all system configuration, everything that FVCOM into the we into the kind of coding. You include if you die module. Okay. It should be no problem. But you do need to modify. But once our coding fully testing, that should be easy. Right? Dr. Lee, are you agree?
Yeah, I agree with you.
Right? Yeah.
Yeah, it's really, really wonderful. Wow. Then
Yeah. Yeah.
will be.
I checked with the professor, Dr. Chi. So he has been finished the coding writing. Then later he testing. He found he not able to run the older version again, like a older module. So then he found then he go debug the coding. He found some kind of order changes. So then the two coins don't understand. So now he able to go back run the FVCOM like original FVCOM in the hybrid coordinate system, no problem right now. But now he need to check every step, because he found if you use like a variable the name exactly same, so then maybe make people confused. That's why he want to introduce the vertical coordinate system. Sometimes you don't know which is sigma coordinate or the z coordinate, right? That's why he said that he like to introduce before he coding he used the all. Today, here is sigma, here's z. But then he found, later for debugger coding can make it really difficult. Because if people don't understand, oh, this is a z, that's a sigma coordinate, but in the low layer, it's not a sigma, it's z. That's why he feels a little bit confusing. So he said for user, user better we have a new variable. Okay, so let you ZZ, for example, it's a sigma coordinate. For ZZ, for example, one something, I don't know he will choose. So they will choose a Z coordinate. So you can see that's which one's Z, which one's sigma. So this way, the people will use it. Now he said that he goes step by step. He said he should be finishing in the early May to check all things. Then we can test it. Yeah. Hello?
Yeah.
Yeah, other students are so quiet today, okay? But before you get a lot of questions, I think the LC couplings to make it too difficult. Don't you intriguing? Right? I sort of, right? So then that's the first step of we want to change the hybrid coordinate. Second step we introduce called a OFI method. Probably I go to Korea, I can give a seminar about this, a new method. But now Dr. Lee has been, make like a eclipse skin working. But no, in-place scheme not working yet, so we still need to working on, but we don't have much time right now. But no, we want to get a hybrid, a vertical hybrid coordinate developer first. Okay, after the developer first, this one is a good thing. So we can update the non-constraint model. Because if you non-constraint model, you use a vertical coordinate system like this right now, hurricane in the deep ocean, right? So you know the result. You get a stronger upwelling because when the resolution not enough, right? But now you get a two coordinate system, so you get a hurricane moving in the deep ocean or the time deep ocean. You don't need to worry about on a short break region get a artificial upwelling, right? Because you can reduce sigma error because sigma only the surface, and that's a layer.
Okay.
So you can make a lot of deep ocean because a lot of region like a 4,000 meter deep, right? So you have to be a lot of sea mount, for example. So you're not interested in the sea mount, you only need the coast region. That's why you want to make it simple. Also, I'm pretty sure the computation should be more efficient than before. So what I'm planning to do is now, after the coding develop, testing, I want a Q1 to apply for global ocean, right?
Yeah.
Global ocean, look at global ocean, particular Arctic Ocean. Okay, run the model, just write the one paper, 6 short paper first. Just before FVCOM model results, like Arctic Ocean, now the new coordinate system work different. Particularly most interesting on the short big region. Because that's a very critical in the short big region, like a Arctic Ocean, like a slope current.
Right. Right.
Because
And also
also
near the fjord.
Yeah.
In the Svalbard and other fjord, there's also very steep slope. Entering the fjord. Yeah.
Because that's in the front strait, they get in the water in, but then the Greenland Sea where the water flowing out is very narrow. But if we can result was pretty good, but however we don't know the speed we did have is probably particularly upwelling we not look yet. But horizontally we can take pretty good results, but vertical upwelling so probably overestimate. That's good way we can determine that. Right? So this way you can get a very nice things can be done. So then I think the Q1 can upgrade his 3D watts into that system too. But once the framework is done, that's just simply we get a module, you can simply change it. Okay, but only need the computer know which is the sigma coordinate layer, up block, which is the low block. This way you can really treat it like a no. I know a lot of people try to solve the sigma error, right? The total way, but I don't think that's really work. If you look my paper, 1995, okay, I said clearly only way to solve the problem make resolution high. The reason because this error can come from very small, the beginning, right? Very small beginning, okay? So because you're not able to resolve a thermal boundary layer. No?
I have another question about can I ask question?
Yeah.
Because if other students doesn't
people
have.
don't ask a question, you can ask a question.
Yeah. Okay. I remember you mentioned about the boundary condition of the temperature at the bottom.
Yeah.
And when we test this zero forcing case, as you said, if this is the slope, and if this is the equal isothermal line, then at this moment the boundary condition try to make the gradient zero at like this.
That's
true. Yes. So is this the only boundary condition that we have to think of?
No.
Is there another method?
No. Okay. Let me use. Okay. Let me use the ball to show you the blackboard. Okay. So that's slope region. Let me do the slope. Okay. So if you had because most ocean model, include the mound, include the pond, include the mound, they assume in the bottom, if you know that's the heat flux temperature, Z equal to 0. So that means that all ocean model and slope region, that's why I think the sigma error is not just so simple sigma error, because your boundary condition also had an error. Because your boundary condition, you make the boundary condition, that's before you put a temperature like this way, when you start running model, they quickly temperature going that way. But true boundary condition, if heat flux equal to 0, it should be normal to the slope, not vertically. But in the Wang, in the Wrong, in the Pang, include all zone, that's the partial T, partial Z equal to 0. That's why then you get a temperature something like this. If you look at your model. So FVCOM doing this way, FVCOM said no, you should doing the temperature normal distribution that's equal to 0. Right? So that means you should get a partial Z, partial M. M is normal to slope equal to 0. Then come out, that's the FVCOM boundary condition in the bottom. So we include a horizontal diffusion. Right? So you not only vertically, you also determine the horizontal diffusion. If you look at my equation, horizontal diffusion coefficient. But then come out another issue, that your horizontal diffusion is correct or not. Right? Because horizontal diffusion, your model to produce a horizontal diffusion, you really don't know your model. That's why you also determine empirically about the horizontal diffusion coefficient. If your horizontal diffusion is overestimate, you get a boundary, you go overestimate. So then that's boundary layer can be thick. If it's too small, right, then you probably the boundary should something like this. Depend on the horizontal diffusion coefficient. No, depend on vertical diffusion coefficient, or depend on the horizontally. But all other model, the global model, they assume that's equal to 0. If we can improve that, we do see if you use this one, you get a stronger upwelling. If you use the way I did this one, so you can reduce upwelling. I had a paper published about this. If you look at my 2007 paper, I mentioned that. But then the question come on, I just do the testing, but the question, how your horizontal diffusion, how you horizontal diffusivity, you model produce too is accurate or not? There is another question. Okay? So that's why the sigma error is not just simply, just say, okay, I put a temperature there, I get a sigma error calculation, but they also related to mixing. Right? But all the global model like this. You probably, a lot of people don't pay attention, just look at this one, they don't look at this. That's why if you look this way, you in the slope region, your upwelling definitely not correct. Right? No, we had a paper compare with wrong FVCOM, wrong model FVCOM. We do find that wrong model overestimate the upwelling in the analytical solution. The reason they use this boundary condition, what they equal to this one. But we use this one, so we can reduce the upwelling, but just have enough resolution, okay? Enough resolution and time, so it's not a sigma error issue, okay? Because right, so we were talking about not only sigma error, okay? So then, you can guarantee small sigma error, but still has a boundary condition can cause another issue. So, so that's why I think, if you use Z coordinate, you ship Z coordinate, right? So this ship Z coordinate, so you had to, I had a lot of mathematical details, like probably, too much technique. So you want to make sure you ship Z, because the ship Z coordinate, for example, slope here, you get a Z coordinate, something like this. So then you have a shear here, right? So here, That's called ship Z. How you can resolve the flux inside that region? That's what we're doing. That's the FVCOM trader doing. So get a ship Z, then we can how to determine that this region, how the flux should be. Pressure gradient, forcing gradient in that kind of Z coordinate system. Right? So they had a limitation. Like among had they had to show the kind of limitation. They had a criterion to determine how you treat this kind of triangle flux. That's called ship Z. Okay. That means ship, not a Z coordinate, ship Z coordinate. Ship Z coordinate means no, you ship, you change the Z coordinate, you make the ship on the slope region. But then you don't need a sigma arrow because your pressure complete the Z level. So now, we already, Dr. Lee has tested the coding. We already make the pressure, horizontal pressure gradient because the most error of sigma arrow come from the horizontal pressure gradient. The 2 big 10. So now we have been changing the horizontal diffusion. We don't really care. We only care about the volume, how the horizontal pressure gradient is volume. That's why you can apply the sigma arrow. So that's why you don't need to worry about gradient anymore. You just I have this volume, how much pressure should be. Okay, so I can use Z coordinate system determine the pressure, driving the sigma arrow, no sigma circulation motion. The reason because I consider volume. Right? So we had two approach. Change the hydrodynamics pressure calculation, also change the coordinate system to make sure you can, don't have a sigma arrow, at least have minimum sigma arrow come out. So after this coding developed, so I will ask my former student to change it for sediment or to change it for non-hydrostatic. So now the people really how to use non-hydrostatic model FVCOM. When they go to the small region, they get a, it's sometimes not working, had a lot of tuner. It's a lot of things not easy. So now we want to make this color system, then you can match it simple because you reduce you can change the pressure calculation, not only hydrostatic, non-hydrostatic. Right? Now that you also had a sigma coordinate, you have to consider 210. Sometimes 210 can cause instability. But it's very small scale, like a cylinder case or something. But then if we change this way, we can reduce we can make the non-hydrostatic model more stable. That's what we hope in the summertime we can get a whole new coding come out. Okay. Any other question?
Wonderful.
This is the last class, right?
Yes, this is the last discussion for this semester.
Okay, good. Okay. If no question, we can wrap up. Okay, thank you for everyone to come to the FVCOM course. And we hope that every year we can have this kind of course offer so we can get a chance to discussing the different question. Listening material is good, but however, I think discussion more important. Okay, you can learn for discussion, can share with you, what we learned before, right? A lot of, we can show you how we feel, right? Because some people always tell you tell me how you success, but I like to show you how you feel, right? So what you can how to treat the problem when you feel, how to deal with the problem. So that's good for discussion, okay?
Right.
Okay,
Yeah.
good.
Yes, thank you so much for everyone joining this. Yes, I want to appreciate everyone who joined in this online course, and this is really a great opportunity for everyone, including me, to discuss all the questions about the FVCOM about the numerical model and the different modules, including sediment, wave, atmosphere. So I really learned a lot. This is my third time to join in this online course, and I think it is still really helpful for me for my study. And I really appreciate everyone. And I really appreciate Dr. Chen for also all the questions. Yeah. And in the future, even though our course has ended today, if you have any question, feel free to send your question to Dr. Chen, to Dr. Me, and we are happy to answer them. And we want to, all we want to do is to make FVCOM better and better. And we will also keep everyone updated with our improvement on the FVCOM model. Yeah. Thank you so much, everyone.
Thank you so much, Dr. Lee. It was really a great time for, as you said, study together. Thank you so much.
Yeah, I think I think probably next semester, next year we want to try to like case study. Right? And if like a issue discussion, we get a case study, we can like a student do a case study, show results for the random model and the discussion. So because you get a question is good. Also, I think you need to make your hand wet. Right? You had to working on. Okay, if you only learn FE theory, you had to working on. So we probably spend more time to working together. Okay, like Dr. Lee can work with your people to set the model. For example, now just the model how you run that. Okay, but this semester I don't see a lot of students running the model. Probably all busy, but we do need to run the model. Okay. Okay, good.
Yeah. Yeah.
Yeah.
Okay.
Sorry, I got a video off. Yeah, the video. Yeah. Any student had any comments or suggestion about for the course? No? Okay. I had a couple Chinese students register the course, but they never show up.
Yeah, that should be for Chinese students.
Yeah, that's why I was scared for Chinese education. So they was register the course, but they never show up. Right? They are never questioning this one here, right? I do know, some kind of, people, I do know some people register the course, they download my materials, the lecture note, they publish it in China. They organize the FECOM, some kind of teaching class. I think a lot of slides come from this course. All right. So then they have to do business, they earn the money. They ask people pay to attend the course. That's very funny. They're supposed to not allowed to do that, but they doing that anyway. Okay, good. So if not, we can wrap up.
Yeah. So
Okay.
thank you so
everyone.
much. Yeah.
Thank you.
Thank you.
Thank you so
Bye-bye.
much. Thank you. Bye-bye.